So welcome everyone to the SICS Data Science Day 2016. So today we're all day going to talk about smart systems, data-driven systems, how to build them and how to deploy them to create smarter and smarter solutions. And just at the beginning, before we have the first speakers up, I'm just going to reflect a little bit about the SICS Data Science Day and where it came from, basically, and how quickly our perspective and the perspective in society has actually changed. We had a SICS Data Science Day last year. Before that, it was the SICS Big Data Day. And before that, it was the SICS Cloud Day. We don't talk about all that different things, to be perfectly honest, during the days. But the perspective has changed really, really quickly, and the public perception about what we do has changed really, really quickly. So, first of all, we have been talking analytics, and it's been a very, very popular topic for many, many years. Nowadays, when we talk advanced analytics, we typically talk about machine learning. And this is something that's not really new. This is something that's been more or less true in, for example, the data mining and knowledge discovery communities for a very long time, that advanced analytics is basically applied machine learning. But it's really, really true in the public awareness now. Now, actually, in regular media and so on, people talk about machine learning, basically. And this is really interesting. And one of these reasons is probably we have had really, really good results in the last few years, basically. This is just one example, but I think it's relatively telling. This is the ImageNet classification error from 2010 up to 2016. And you can see where deep neural networks technology that I'm sure you're going to hear a little bit more about during the day, when they started to come in, and how quickly the error has started to decrease. Now we're below human error, basically, on these databases. So these neural networks perform really, really well on this type of data. And if we then look at the general interest in machine learning, I think this is a rather telling graph. Now there is actually no yearly labels on the graph there, but NIPS is one of the premier conferences for machine learning in the world. This is the attendance the last few years. The last blue graph there is attendance 2015. We expect it to be almost 4,000 people 2016, well, basically next week, I guess. So you can see what's happened. It's gone from a very big conference to a massive conference. And this also really reflects the interest in machine learning as it stands now. But during this spring, we put together a research program at SICS, a new research program. And in that, when we did that, we think also about applications. How are we going to use these scalable, distributed computational systems to produce machine learning and then produce applications? Because we build applications for real-world scenarios and so on. And when we think about that, we start thinking about AI. Because we build systems that need to interact with the world, that need to optimize processes, that need to schedule things, and actually do that in an interactive online manner. So we're basically thinking more and more about general AI problems. And it's not only us. Again, public awareness has sort of shifted towards AI with some really, really public good results. For example, DeepMind's AlphaGo that beat a grandmaster in Go just this year, show that at least for very narrow applications, we can build really, really strong AI. Now, this is a very narrow application. The question today that we're going to have a look at, can we look at AI in a wider perspective, and how do we get to wider and stronger AI, basically? But if we want to get to stronger and wider AI and more useful systems, so what do we have to look at? So there are lots and lots of things, but I'm just going to present a few of those things that actually drive us at SICS in our research. And what we want to create is, from our machine learning analytics models and things like that, we want to create actionable knowledge, something that humans or machines can actually make real decisions on and use when they optimize a system, trying to understand the world or something like that. And we focus on a few questions, basically. We're looking at timely results. We don't just want to have systems that run something in a huge batch of data, produces a model, and produces a predictor. We want to follow the world, continuously update our models, and look at the massive amounts of streaming data that are out there. This means building systems that can handle these data streams and can update these models in real time. And we're actually quite far from really, really understanding how to build these systems. We want to look at uncertainty measures because we want to have models that can tell us how unsure they are about their predictions. Without that, it's very, very difficult to rely and base a decision on their output. Some of the models we have today are pretty good at that. They're not necessarily scalable. Some of the very successful models, like deep neural networks, can use massive amounts of data, produce fantastic results, but they're not really good at specifying how sure they are on a decision, basically. And this is something we need to fix. And the third bullet point is something that is very difficult. But we need to start to look at causation and causal relationships instead of just correlation, because it's very, very difficult to interpret just correlation. Finally, we want to look at interpretable models. Again, something that, for example, deep neural networks are not all that good at. They're more or less black box models that we cannot ask them really to explain how they came to a decision. And this is something we need. And we also need models that can actually reason about the world. And of course, we need to start building more efficient models, because in lots of cases we don't have huge amounts of data, but very few examples. So we need to build efficient models. So these are some of the things that we're looking at. And just to tell you what we call our approach, we call it continuous deep analytics. We want to build machine learning and analytics systems, large-scale machine learning systems that produces actionable, interpretable causal models of the world in real time on massive data streams, basically. And to do that, we have to fix a couple of basic things. Some things that I've already been talking about. Large-scale machine learning systems need to scale better. They need to be interpretable so that the decision-making, the output is actually actionable. But we also need to focus a lot of our attention at actually building the systems that support these large-scale machine learning systems, actually. Those technologies are currently quite lacking for some of the general models. And we need to build these things together. So this is what we do. This is what we're going to do. This is what we're planning to do. And as it happens, our program today really, really fits well into our picture here, basically. So the shift to AI and what data science means in society and so on, we're going to have in front here, we have two excellent speakers. Vijay Saraswat from IBM is going to talk about actually reasoning with machine learning models and logic. And later in the afternoon, Devdutt Dubhashi is going to talk about data science in a larger perspective, basically, and its place in society and some challenges around that. We're going to talk a little bit about tools and platforms. What are these systems actually going to run on, and what do we need to fix? And a lot of these things that we're building right now rely on graph representations. And Paris Carbon from KTH is going to talk about graph stream processing. How do we process very, very large graphs in real time on streaming data? How do we build platforms for that? And Jim Dowling is later going to talk about Hadoop and how do we actually make it really fast? Because right now, the speed of Hadoop access is, well, it's somewhat lacking, but we're going to hear how to fix that, basically. We're going to talk a lot about methods and algorithms. We're lucky to have Jacob Forster from Oxford that's going to talk about using deep multi-agent reinforcement learning, deep learning, and actually building multiple agents that learn to communicate with each other. in a sort of wider AI perspective. We're going to look at how do we build models of the world that we can actually understand and interpret and perhaps use as a basis for reasoning. Olof Jarnerup at SICS is going to talk about that. And we're going to have a look at uncertainty and present one method of dealing with how to actually specify how certain a model is of its prediction with Henrik Boström from Stockholm University. And I'm happy to say also SICS. And of course, nothing of this exists in a vacuum. We want to build applications. We want to have these things running in the real world, basically. And to span up a few examples, we have some excellent speakers here. We have Boxer Rang that's going to talk about machine learning in the product, actually doing really, really smart A/B testing and so on. He's from Spotify. We're going to talk about image data and video data and how we can, just by looking at video, understand human emotion. We're going to look at real-time anomaly detection in networks with Jason Zhao from Ericsson. And finally, we're going to take a little bit of a wider perspective. What does it mean for a company that has not been data-driven before? For example, if we compare to Spotify, that is a fundamentally data-driven company. What does it mean for example, Scania? How do they become a data-driven company? Right. And let's not go through the program in detail. Let's just do some highlights. We're going to have a few presentations now in the morning, and at 10:40 there will be a 20-minute coffee break. At 12 o'clock there is lunch, and there are lots of lunch restaurants around in this area in Kista that you can visit. And at 1 o'clock we start again. 14:20 coffee break, and at around 4 o'clock we'll have our closing statements and end the day. Right. And now, a message from our sponsors. SICS will be part of RISE Research Institutes and will change name and logo in the beginning of 2017. So don't be afraid or worried if you see this new logo. This is the new us. This is SICS in the future. We want you to talk to the speakers. It's courteous, it's the nice thing to do. No, actually, what we're talking about is actually, there is a cool app up here that you can actually log into. There is a password on the screen. And in real time, just write your questions, and they will show up on screen here. And we can have a bit of an interaction. So please do that. Please try this out. Right. And the Wi-Fi login should be in the program folder, and I think it's written over there at some paper as well. Not that you're going to need it. You're going to be spending time looking at the presentations, right? Some more details. You can use Twitter. 6 Software Week, hashtag 6 Software Week. You can look at the talks later. You can download them at this URL later on. And there will be coffee served out here. And yes, lunch is, in whatever lunch restaurant you choose around here. And that's it for me.